Well, good morning, everybody. This is Friday, November 1st, 2019, day after Halloween. Hope y'all didn't get too much sugar last night. We do like our candy, don't we? It's cool and clear here in Irving, Texas, and I was doing some more drawing and back to the drawing board, if you will, and wanted to take a patent and dissect the field motor that Nikola Tesla patented years ago, and understanding the split in the field. How he did it, he paralleled his split, and it's kind of like interpreting what it is that he was doing. But one of the things I really found curious is the 80 degree split of 240 of 240s in the design. So basically, when you start analyzing the alternator and the alternator field, you understand the coil that's in this field, okay? And that coil, the way that it's wound is like this, okay? And so we know that when we have a coil like that and you energize these two poles right here, whether you energize them this way or energize them that way, that one side is going to be biased north radiation, and the other side is going to be biased south radiation. Okay, and so in an alternator, it's evenly collected. This, one side's the north side, one side's the south side, and that's dependent on the DC current, which way it's flipped on the unit. Okay, and I've got to go back and look at the alternator to really determine where the start winding is in here. I've never actually taken one of these apart down to the core right here, so I'm going to assume that the inside is the start, which would be the negative post, and the outside is the positive post. I'm going to just kind of state that, but it could be the other way around. We get flipped every which way. But the whole point that I'm trying to make is when Tesla was drawing up the field motors, that's basically what he was doing, was taking that field and harvesting one side for his dynamos. Okay. And so a dynamo, if you can imagine half of this running in the circuit, and you could parallel these right here to the other one of the opposite polarity for the field, and then collect the other side, then you have a potential that's separated, okay? And they're still sending a field, but then at that point, you could synchronize the two units and they would go into parametric oscillation with each other in that series circuit. Then from there, you could take that, run it through a spark gap, run that through your Tesla type coils. And I'm kind of beginning to understand the difference in dynamos, alternators, and generators. Okay. And so, you're going to have a dynamic system, and you're going to have a biased system, which south magnet, like we learned from the Bedini wheel, as north magnets, north facing magnets. So let's say that this face right here is biased south just because of the battery connection, and we did away with the other side, but put the other side over here. Then we have two potentials. Okay, which would give us a bigger swing, because as we know, when you put something in motion and spin it up, it wants to stay in that motion, okay? And in that type configuration, you have a wider separation that you can put through. So just kind of wanted to give a heads up that I'm finding that automatic flipping pole through the basket weave technology. And like I said, I found that off my magnets and friction, that when you analyze the drawing, and I want other people to find the drawing and analyze it for themselves, but you'll see that the fields, the way that they're drawn up, I believe those were adjustable fields too. I believe that his whole idea and scheme in doing that was to be able to adjust the field in a monopolar way. In other words, they were all facing the same way, but he was able to turn them on top of each other and adjust that field for different effects. And then to be a consumptive component, they balanced it, and that way you had to have power, more power, a lot more power. You weren't amplifying, automatically amplifying. You were actually using the hysteresis. I can write it, but I can't say it. Hysteresis of the metal that automatically has the flipping pole. So that flipping, to me, is what is the PMH is about, and understanding that. I think originally on the field magnet, they had their coil that was wrapped around this way, and they basically had two fields that went over just one way off of one side, and then you could change the window in that field, what it was. It'd be very easy to do that. Just most people don't look at it. So I'm gonna see if we can't make this from an alternator to a dynamo. Like I said, I've never taken one of these apart and pressed them apart, and see if you can separate that end of the coil off of it and just run one side of it. And then, like I said, get another coil that's like this, flip it over, and get the two to work with each other in series, and then show the amplification of those two operating together to operate the third unit of the same type, to either make it amplify in current or amplify in voltage. So the whole thing's about current. When I first started with the asymmetrical side, I wanted to build my motor to draw 10 amps. In other words, I built the windings and everything in my original motor to handle 10 amps, and then came up with the asymmetrical winding and worked from there. As we know, this is about an 80 amp alternator in the series. So properly done, I've got to suspect, if you're just doing one side, that the amplification could be even much more than that. So let's call this side the north side, like the Bedini wheel, and do half of that. So that's what I'm playing with today. And the switching equipment I haven't quite chosen yet. I've got another person that I'm talking to that's supposed to come up with a good solution for us. Like I said yesterday, the normal off-the-shelf units are, for drivers, they're not very expensive. They're about $200 for the 120 to 3-phase 200 volt programmable units. But want to find something a little more robust that'd be like mine, and the I'm not going to show you how to modify those when they come out. It'd be pretty simple to do, but I'm not going to go there. But I can show you this part of what I'm working on and why, getting to understand the difference in dynamos, alternators, generators. And one's passive, one's active, and one's dynamic. And so you combine the three separately and you can come up with some pretty neat stuff. So just kind of separate that and we'll see where it goes. Hope you guys have a great day, and we'll see you next trip.